Hey everyone, and welcome to The Explainer. Today, we are unpacking a highly technical, but honestly, absolutely fascinating new research paper by Seng Xu and their team. We're looking at a breakthrough that pretty much challenges everything we thought we knew about how big an AI model actually needs to be to perform high-level, verifiable reasoning. Get this, the massive breakthrough we're talking about today comes in a package so small that you could, theoretically, run it on standard consumer hardware. It is just an incredible piece of research, so let's jump right in.
Let's start with the elephant in the room, the massive question that's dominating the entire AI industry right now. Does frontier-level AI actually require massive models? For years, the assumption has been a resounding yes. We've basically been told that to get true high-level reasoning, you have to throw billions upon billions or even trillions of parameters at the problem. But what if that foundational assumption is flawed? Well, that is exactly the stakes of the research we are looking at today.
Here is our roadmap for today. First, the small AI revolution. Second, we'll meet VibeThinker 3B. Third, the optimized training pipeline. Fourth, crushing the benchmarks. And finally, the compression coverage hypothesis. All right, let's kick things off with Section 1, the small AI revolution, challenging the status quo.
You know, right now, the AI arena is completely dominated by Goliaths. The fundamental assumption has always been that bigger is automatically better. If you want an AI to solve complex math, write flawless code, or logically reason through a really multi-step problem, the standard operating procedure is just to rely on massive parameter-dense flagship models. We're talking about giants so insanely resource-heavy that they require literal warehouses of supercomputers just to function.
Which brings us to Section 2. Let's meet the star of the show, VibeThinker 3B, the underdog. We really have a classic David versus Goliath dynamic here. On one side, you've got VibeThinker 3B. It's a strictly small regime model with just 3 billion parameters. That's small enough that you could run it on a high-end laptop. And on the other side, the paper specifically calls out today's flagship models. Think DeepSeek V3.2, GLM5, and Gemini 3 Pro. These flagships are orders of magnitude larger and demand just astronomical compute power. So the researchers basically wanted to see, could David beat Goliath at high-level verifiable reasoning?
So, how did they do it? That leads into Section 3, the optimized training pipeline, or the training dojo.
Now, the crucial thing to remember is you can't just shrink a model and magically expect it to be smart, right? You have to train it smarter. Building on a highly efficient training philosophy called spectrum to signal, the researchers systematically enhanced this compact model through an incredibly optimized three-step pipeline. Step 1 is curriculum-based supervised fine-tuning, which basically means teaching the model through structured, progressively more difficult examples. Step 2 is multi-domain reinforcement learning, letting the model practice and rewarding it when it reasons correctly across different subjects. And Step 3 is offline self-distillation, refining and purifying that knowledge so the model becomes highly efficient. It's this exact pipeline that turned a tiny model into a total reasoning powerhouse.
Okay, let's look at the actual results in Section 4, crushing the benchmarks, the knockout results.
97.1. Just let that number sink in for a second. In the world of AI testing, the AMME26 benchmark is a notoriously demanding, rigorous test of mathematical and logical reasoning. Out of the box, VibeThinker 3B natively hit a score of 94.3, which is already just incredible. But when the researchers applied something called claim-level test time scaling, which is essentially giving the AI extra time to double-check its own logic and verify its steps during the test, that score skyrocketed to a jaw-dropping 97.1. We are looking at a 3 billion parameter model achieving literal frontier-level performance.
And it's not just a math whiz. On the LiveCodeBench coding evaluation, it scores an 80.2 pass at 1 rate. That means it gets the code right on the very first try over 80% of the time. Even wilder, on recent entirely unseen LeetCode contests, it boasts a 96.1% acceptance rate. That proves it's not just memorizing old training data. It generalizes brilliantly to brand new, out-of-distribution problems. Finally, it scored a 93.4 on IFEval, which stands for Instruction Following Evaluation. This proves that despite getting all these new reasoning powers, the model hasn't become erratic. It still strictly follows user instructions, matching or even beating those giant flagship models we talked about earlier.
This leads us to the most profound part of our explainer, Section 5, the compression coverage hypothesis, the big theory.
So why does all of this actually matter? Well, the researchers point out that this VibeThinker 3B project is actually an extension of their previous work on an even smaller 1.5 billion parameter model. By pushing the boundaries like this, they're suggesting a major paradigm shift in AI architecture, literally separating reasoning from knowledge.
And this is where they introduce their new theory, the parametric compression coverage hypothesis. Let's break this down, because it's a game changer. They propose that verifiable reasoning, the actual logic, the step-by-step deduction, is highly compressible. You can fit it into what they call compact reasoning cores. Think of it like a tiny, incredibly powerful engine. On the flip side, open domain knowledge, memorizing millions of random facts, historical dates, and long-tail scenarios, that still requires broad parameter coverage. It needs a giant library. So the takeaway, you don't need a massive model to think well. You only need a massive model if you want it to memorize the entire internet.
There's a quote right from the paper's abstract that I just have to share, because it completely reframes how we should view the future trajectory of AI. They write, "Compact models are not merely deployment-efficient substitutes, but a complementary path toward frontier-level performance in parameter-dense capability regimes." So they aren't just cheap knockoffs meant to run on your phone. They're a legitimate, complementary path to top-tier, frontier-level AI performance.
I'm going to leave you with this final thought. If frontier-level reasoning can be compressed into just 3 billion parameters today, what will the next generation of small models be capable of tomorrow? We are truly entering an era where efficiency might just beat sheer scale, and the implications for our tech are absolutely boundless. Thank you so much for joining me for this explainer on the Vibe Thinker 3B paper. Keep questioning the status quo and stay curious.